With a convex lens, you can create an image of an object, for instance this red arrow here. Now where will the lens form an image of the arrow? To determine this, you can draw a ray diagram. Before we can draw a ray diagram, we need some new words. First of all, the lens is represented by a vertical line. Plus for convex and minus for concave. Perpendicular to the lens is the principal axis. In the middle is the optical center, and to the left and to the right are the principal focuses. The distance from the principal focus to the optical center is called the focal length. Now where will the lens form an image of the arrow? First of all, remember that light is scattered by the arrow in all kinds of directions. For instance, from the tip of the arrow, these are some directions in which the light is scattered. We are only interested in rays which are scattered towards the lens. There are three principal rays. The first one is parallel to the principal axis and it refracts through the principal focus. The second principal ray goes through the optical center and continues in a straight line. The third principal ray goes through the principal focus first and then refracts parallel to the principal axis. These three principal rays will meet in one point, and this is where the image is formed, upside down on the other side of the lens. Example 1. The object distance is twice the focal length. Construct the image that is formed by the lens. Now you can see that the image is upside down and has an equal size as the object, and the distance is the same as the object distance. Example 2. The object is between the focal point and the lens. Construct the image that is formed by the lens. Now you can see these two principal rays will never meet. But if your eye is here, your eye can form an image on the retina. To know where the image will be formed, we will extend the two rays to the other side, and we will see they will be appearing to be coming from this point. This is where an image is formed. This is a virtual image because it is not formed on a piece of paper or a screen. It is virtual, and a virtual image which is formed by your eye. And you can see that it is larger than the object. This is what happens with a magnifying glass. Now what about the third principal ray? Remember that the third principal ray goes to the focal point, the principal focus, but it will never reach the lens. We can extend it to the other side so that it will reach the lens, and it is refracted parallel to the principal axis. Now this ray of light parallel to the principal axis will appear to be coming from the direction in this direction, and you can see that if you create a dotted line, you will reach the same point where the other two principal rays appear to be coming from.